Oh. What's another name for x equals 0? These are all what kind of lines? It's in the name of the thing we just did.
They're all
What's
vertical lines?
Vertical lines. Holy shit. So x equals 0 is a vertical line where x is 0. What is that? So a vertical line that goes through
x-axis.
Y-axis.
Y-axis, damn it.
Yeah. So it's a vertical line going through 0. It's the y-axis. What does it mean then? What's true about vertical asymptotes that is not true about horizontal asymptotes? What can you not do?
You can't cross them.
Can't cross it. So if one of the vertical asymptotes is the y-axis, can there be any y-intercepts?
No.
No. There you go. That's why there's none. Did you have to do this first? No. You plug a 0 in to the function, and you see the bottom is 0, so you know there's no y-intercepts. Right? How do you find the y-intercept? You make x 0. What if the bottom is 0 when you do that? Well, then there's none of that, right? You can't do it. But now you see why, because the y-axis is actually a vertical asymptote. Is everybody with me? It all comes together. All right, maybe. What about horizontal asymptote? Now this is what you're really interested in. It's kind of bugging me. Maybe let me make that 10 a little bit neater. Gather 8.
Horizontal asymptote would just be y equals 0, right?
Yes, why?
Because the degree of the denominator is greater than that of the numerator.
Yes. The function's denominator overwhelms the whole thing. So it gets bigger and bigger on the bottom faster than the top. So the whole thing goes to 0. If it was the other way around, I would have had a slant asymptote or an oblique asymptote, if you feel like being like that.
What was the equation to find a slant asymptote?
No equation, you just long divide.
Okay.
And it's the whole part of what you get when you long divide. Yep. All right, so let's see what we got here. I don't have any outputs. Do you guys see that? Do you see what I mean? Like y-intercept is normally an output. So let's graph the x-intercepts. Jeff, where are you? There you are. 5, 0, -2, 0. Let's do the asymptotes. There's an asymptote here, which always kind of sucks. You missed, Jeff. Be quiet. The only way you can really show an asymptote there is to do that. And then there's one at 1, and there's one at, oh, crappity doodah. Am I drunk? I can't draw a straight line, officer. Jesus. Rah! All right. It's kind of gross. Now, and then my horizontal asymptote is the y-axis. That's nice. So what are some points I can plug in? What are some numbers, some inputs to see where this function is?
-3.
Yeah, so we can plug, sure, I like it, -3. So let's see, this is -1, -2, -3. So if we look at f of -3, let's see what that is. It would be -8 times -1 divided by -3 times -4 times -2. Neato. Well, these all cancel. Do you guys see what I'm doing? It's so much easier to plug stuff into the factored form. So I get -1/3. So these cancel, right? These positives cancel, these cancel with that. And then these negatives cancel, so you get -1/3, okay. F of -3 is -1/3, but I don't know what I'm just gonna hold on to that for a minute. So I'm plugging a few points in, not only to see where the function is, but also to see what scale I wanna make the y-axis. Now, what's a really important input that I have zero idea about? All right.
Would you try to figure out whatever is between the asymptotes?
Totally. So I've got 3 regions. Do you guys see that? I got this region, I got this region, and I got this region. All right, somebody suggested a point in this region, so region 1. I got region 2, this little freaky, little tiny region. And are there any x-intercepts in here? No. Which means what? What's it going to have to look like in there?
A parabola.
Yeah, either a parabola up here or a parabola down there. So I just need to know what f of 0. I can't do f of 0 though, can I?
But isn't
Oh
there
shit.
an
Oh yeah.
asymptote?
Sorry. I'm with you. I'm with you. This is why it's better to not have such a bold y-axis. There's actually region 2, region 3. It's even prettier than I thought. So we actually can't do 0. We have to figure out, it's not going to look like a parabola. Not through this whole thing. It's going to have to be in here and in here, but it will look like parabolas in both of those. This is going to be really funkadelic because I made it that way. All right, I really want you guys to be with me. There's no x-intercepts in here. There's no x-intercepts in here. So it's going to have to be totally above it or totally below it. So what do I really need to plug in? I need to plug in 2 more things for that middle region, the middle regions.
-1/2 and 1/2.
Yeah. -1/2 and 1/2. Oh, that's just yummy. Man, what's more important about this problem is not specifically what I'm doing, but specifically why I'm doing what I'm doing. Do you understand that, guys? What made me go down this road? And then, you actually told me what to do, but you saw where I was going, because I don't know what's happening in this little region in here, and this little region in here. The only way I can figure out what's happening there is to plug something in. So let's see. Oh, this is gonna be gross. Shit. I really don't want to do this. Well, let's see. If I do it in the non-factored form, maybe this will be not as bad. 1/8. Oh my gosh, this is gross. It's negative. Oh crap. Did I forget the negative idea? Yeah, you did, Jeff. Come on, Jeff. -1/8 plus 1/2. This is gross. Let's see. That'll be 7/4 minus. Why am I doing this? You can plug it in your calculators. Let's see. 7/4 minus 10 minus. So what is that? That's 1.75 minus 10 is -8.25. Is that right? Over -1/8 plus 4/8 is 3/8, which is going to be roughly. Oh, let's see. I can do this. Come on, you can do this. 64, 68 divided by 3, 22.333. Is that right? That's funkadelic, man. I don't know if I trust myself doing that. Are you guys okay out there? I didn't have to do that in my head. I don't know why I wanted to, and nobody said, Jeff, don't be crazy. And you're all like, we're not here to do that for you, man. 1/4 plus 3, so plus 6/4, yeah. Minus 10, bam, divided by 1/2 minus 1/8. Oh, it's just -22. I don't know. That's interesting. Why did I think it was worse than that? So I just get -22, period. Okay. All right, I'm going to assume you guys are with me out there. And then, of course, for the same, so -22. So it's like, now I'm getting a better idea about what I want my scale to be on the y-axis, right? Get out of there. And then 1/2.
Is 30.
Thank you. Good Lord. It's about time somebody saved me from myself. So let's make our scale. I want to get up to 30. So let's make it 8, 16, 24, 32. Sure. So there's one. Oh, yeah, there's not. It's over there. No, it isn't even. It's on the other side, Jeff. You'll get it. You'll get it. All right. Get too excited. Then down here is 8, negative 16, negative 24. What did I get? Negative 22. So this is negative 22 right here and 30 right there. So it's going up from there. Weehaw! And it's going down from there. Jihad. All right. And back here, so now we can plot this point. Negative 1/3 is what we got for negative 3. Now, this is where it gets really interesting. Now, stay with me. What's the multiplicity at the root negative 2? In fact, what's the multiplicity at both roots?
1.
So it's going to go through or touch?
Go through it.
Go through. And it's supposed to be at negative 3. It's supposed to be at negative 1/3, right? So can it start down here and go up? Or does it have to start up here and go down?
Has to start from the top and go down.
Exactly, because it's going to go through, and then it's going to do one of these neat things. Because there's an asymptote here, remember? At the x-axis. And then I can do something, the same idea on this other side up here. I can plug a point in here. So I would suggest we just plug 2 in. What happens if we plug 2 in? So f of 2, get out of there. Urgh, stop it. Sorry. F of 2 would be, let's see, negative 3 times 4, negative 12 divided by 2 times 1 times 3 divided by 6. Now I get negative 2 maybe? That's neat. So the same idea, it's got to go through here. So it's going to come from down here. Go through there. Yeah, this is kind of gross, but too bad for all of us. It's going to come from down here. It's going to go through here, and then it's going to come back down like that. I'm almost certain it doesn't look exactly like that, but it's pretty gross. Now I'm curious. Let's take a look at this thing in the calculator. I knew this was going to be gross. I just didn't know how gross. No shit. Jeff. There you go, buddy. Let's see, zoom 6 and then window. Let's see if this looks at all like it. Yeah, it looks right. All right, and then window. I'm going to go up to, what was it, 30, yeah, let's say 32, down to negative 32. Dude, let's see. Oh, that's funky. Oh, that's so cool. All right. I don't know why I did this on my like real life calculator, but too bad. Do you guys see that? Or no, you can't really see it, can you? There we go. Hold on. You see Athena. There we go. Neato. Okay. So that was the question somebody asked earlier. Is it okay to check my work on the calculator? Of course it is. Holy shit. I don't understand you if you don't, right? Just don't look at the calculator and copy from it, because that's really easy for me to tell that happened, because you guys don't know how to do that right. Right? You'd have to take a whole class on just how to copy things and make it look as if you didn't. Trust me, you know, at least a semester, if not 2. Let me see. Did I miss any other questions before? Let me see. Can you do a problem? Can you, so on the final, Fine. Okay, here we go. So I'm up to date.
Your face is blurry.
Oh yeah. Oh, this is how I actually look. Let me turn the filter on. I don't know which one's better. Probably the blurry. All right, I've got plenty of blank space here. So somebody's asking me about finding cosecant secant without a calculator. So I'm guessing you mean, you don't just mean something like this. If I ask you this kind of question, you really have to be very, very happy. That has to make you go, oh, good. So take a minute and do this. Whoa, all right, now the questions are coming in fast. Hold on, let's do one thing at a time. So what I always do, I'm going to ask you to do this to help me and to help yourself. I'm going to say first, plot where this is, because a lot of you don't, and then you make silly mistakes. Where is 240 degrees?
It's 60 in quadrant 3.
Yeah, good. All right, so the reference angle is 60 and it's in quadrant 3 because that's 60 degrees past 180. And of course, secant in that quadrant is going to have what SIGN? What sign?
Negative.
SIGN. Negative. So this is equivalent to negative. And secant is 1 over
Cosine.
cosine of 60. So you see how much work I just did ahead of time for myself. I rewrote this entirely in terms of a base trig function, reference angle, and the sine. So I got all that out of the way. Now I can just focus on doing what the hell this is. And of course, what is the cosine of 60?
1/2.
Yeah, so then you get -2, done. Now, I'm pretty sure that's not, well, maybe, I don't know. Is that the kind of problem you were asking about? Private chatter? Hello? Ground control to me. Oh, let's see. He's got a specific, like C, 12C. Okay, thank you. Oh, with the inverse stuff going on. Is that what you mean? With some inverse Nikes. All right, so let's see. So what if I ask you for the cotangent of the inverse cosecant of 5/2? What do you do on that thing?
Draw the triangle.
Inverse trig can be represented by the triangle. What's going to be
about your 12C. I think, unless I did it wrong, with the square root, you missed a +2. So it's like y squared plus 2y plus 2.
It's very possible.
Because like it's like c squared equals y plus 1 squared plus 1 squared.
Oh, I see what I did.
And then
Yeah,
when
so
you take the square root.
+2 there. Yeah, thank you.
Yeah, I noticed that as well.
Thank you. I still think I averaged somewhere in the 90s on my practice final answer key. All right. So where does 5 go? Where does 2 go?
5 goes on the hypotenuse and 2 goes on the left side of the right angle.
The y.
Or
The
y-axis, yeah.
Yes. Because cosecant is related to sine. I love it. And the cotangent is going to be what side over what side?
X over Y.
Yeah, good. There you go. So if I just figure out the X, and let's see if Jeff can do it now that we're live. So 25 minus 4 is 21. So square root of 21. So then what's the answer?
Square root of 21 over 2.
Done. Yay. Now I also like to give you problems like, I don't know, sine of twice inverse tangent of x over x minus 3, right? You're all excited when I do that. What do you have to use first, of course, on this, if I ask this kind of problem?
Is it the double angle formula?
Yeah, totally. So what's sine of twice theta?
2 sine theta cosine theta.
Yeah, totally. So then it just becomes two of the kind of problems we did up here. 2 sine of this weird thing, cosine of this weird. It's not even really Jeff. Okay. Cosine of this weird thing. There we go. So make sure that what you're putting inside of the trig stuff are actual angles, right? So that's an angle. That's an angle. I like it. Become a 3. So now the nice thing about this is, even though there's 2 parts to this, I just have one triangle to make, right? So it's tangent. So it's going to be x minus 3. And this will be the square root of 2x squared minus 6x plus 9. Right? If you square this and add them together, are you guys all with me out there? And now I can build the sine of that and the cosine of that and multiply them together. So it'll be x over the square root of business times x minus 3 over
What
the
about
square root.
the other x squared? Isn't it also added into the square root?
Yeah, that's why it's 2x squared.
Okay.
And so then you get 2x minus 3 over business. Hopefully everybody understands the B and the B means business and the business means all this shit. Right? Hey, Jeff, am I allowed to do that on the phone? Yeah, of course you are. Right? If you call this B, if you're like, I don't want to write that, I got to write it multiple times. I don't want to. Well, that's what math is here for you for, isn't it? That's what math is all about. Is I don't want to write all this shit. Math goes, I'm here for you. I got shorthand ways to write so many things. As long as the answer doesn't have a B in it, or something, and you never have to do this if you don't want to either. If you don't really understand what I just did, you don't have to. All right, let me see. Did I miss something else? Oh yeah, somebody's asking for a problem from 11.4. Let's see, what was 11.4 all about? Let's see, do I have the book open? No, Jeff. Good job, buddy. All right, let's see. Here we go. Shlabam. Oh, what's this? Somebody's talking to me. Hold on. Let's see. 11.4. Oh, partial fractions. Right, I guess that's what that is. All right. Yeah, we can do a problem like that. Do you have a suggestion or? Hold on. So I know you guys can't all see all the chat I'm getting because people are sending me. So don't worry. I'm going to get to your question. Okay. Hello. Did you have a specific one you want to look at or just any of these? Okay. I'm not going to get anything else. Okay. Okay, so let's see. Let's just do, let's do 27. Why not? You guys want to do 27? Oh, dear God, Jeff. All right, let's do 27. Let me see if I can zoom in on that a little bit. Ooh,
We can't see anything you're doing.
it's just for me right now. All right, hold on. See. All right, here we go. So let's do this one. Somebody was asking for a problem from 11.4. They didn't say anything specific, so I got to pick. Go ahead and take a minute. The nice thing, what's nice about 27? As you know, compared to 26, maybe. What's nice?
It's already factored for us.
Okay, so can you write what this would be in terms of A, B, C, whatever?
Wouldn't it be a over 2x and then b over x plus 1 and then c over x plus 1 squared?
Kick ass. Now see real quick on a problem like this down here, C31, right? It would be a over x plus 2 plus what goes on top of x squared plus x plus 3?
Bx plus c.
Yeah, so the top has always got to be 1 degree less than the bottom. And you might say, well, that's the second degree. No, that's 2 first degrees. So it really, really is a first degree part. That's why the top is 1 degree less. It's a number on top. So pretty cool with what we've done so far, which is not much. I don't know. I should have followed up with that. Somebody's like, I was going to ask a question until you said that, Jeff. Now I feel dumb. No, come on. Let me know if there's a problem with what we've done so far. What do I do next? What do I do next?
Least common denominator.
I just multiply both sides by this thing. So each thing, whatever it already has, it's going to pick up the other stuff. So this is going to pick up this. Does that make sense? Because if I multiply by this whole thing, 2x is going to cancel here and it's going to pick up this. So I prefer just to think about it in terms of what's it going to pick up. B is going to pick up a 2x and another x plus 1, and C is going to pick up a 2x. Because whatever it's got will cancel with itself when I multiply by all that business. I have no idea which way you prefer. I really hope you guys use the pick a number for x approach, at least as far as you can, because it makes it a lot easier, right? If you don't want to, then don't complain if you're running out of time. So what can I make x equal? What's a couple of good things?
-1.
Yes, because that's going to kill this piece and this piece. So if x is -1, what do I get here? I get 5 minus 20 plus 8. Jeff, don't write 5. We can do it. All right, man. 5 minus 20 is -15 plus 8 is -7 is supposed to equal 2c. No, what am I talking about? -1, so -2c. How's that sound? Are you guys with me? Does everybody see that? Anybody not see that? I got a nice small core group of people here, so don't feel like you're going to slow anything down if you ask a question. So then I know C is 7/2. That's kind of gross. I'm going to hold on to that for a minute. Well, I mean, it doesn't matter. What can I make x next? I don't know why I put that over there. That's kind of dumb.
0.
Yeah, if x is 0, then I get 8 equals a. Oh, wow. That kicks ass. Because the other two die. Why do the other two die? Because they both have an x term, so they're going to die. Now, the only thing I don't know is b. So how am I going to figure out what b is?
Could you like plug in A and C and then isolate B and see like what coefficient would be left over?
Yeah, you actually could, but well, actually it wouldn't be as bad as I think, but there's a bit of a quicker way. Let me see how much you guys can see this. Can you see what your x squared terms would be from this side without doing much work? There wouldn't be one from here, would there? That's no x squared term here, right? Okay. What about here? Wouldn't it be 2bx squared, right? 2b x squared. What about here? It would be a x squared, right? So what's 2b plus a have to be? 5. Do you see that? So I'm doing a combination of things. I did the pick a variable value for x and then figure out a letter from that. And now I'm going to do the equating coefficients thing, but I've only got to write one relationship down, and I picked the easiest one to see. I don't know if you guys are with me at all, because now I can say 2b plus 8 equals 5, right? Because I know a is 8. So then b has to be subtract 8 divided by 2, negative 3 halves. Is that all right? And again, if you don't want to do it exactly the way I did it, there's other ways to do this.
Wait, where'd you get the 2b? Is it from like the c and the b with the 2x?
No. Watch right here, right here. If you were to multiply this out, would you not pick up 2x squared plus 2x?
Oh, yeah, okay.
So then there would be a 2bx squared. So there's 2b x squared plus a x squared equals 5x squared. So it's equating the coefficients of the x squared term. You could have picked any term you wanted to. Also, whoever said to plug these in, that'll work too. But do you see how that's going to take longer than it needs to?
Can we
Yeah,
do
it was just an
31?
idea.
No, it's not a bad idea. I really want you to understand, but and again, if you're in the heat of the moment and you can't think of the quickest way to do it, you think of the only way you can think to do it and you do it. So that's, and you just do it. I understand that. And it would work. What you said would work. What one? 31? 31, yeah? Okay. Let me
Yeah, I
see.
was just thinking because we already started it and I want to one more in my brain.
All right. The bad thing is I can't, well, yeah, I think, well, if I scroll, I'm gonna, well, let's see if I can get away with this. Now, see, that's gonna happen. That's no good. Okay. So let's see if I can fit this in here. Get over there. So here's 31. So when you multiply things through, this side loses all of its bottom. And what does A pick up?
X squared plus x plus 3.
I really hope people aren't saying anything because they totally understand what that means. And what's bx plus b gonna bx plus c gonna pick up?
X plus 2.
X plus 2, because it had this, that's going to cancel when you multiply by this, and the thing is going to stay alive is that. That's why they pick up what they don't already have. What's the value of x that would work here to try to do something with?
-2.
-2. I like it. So if x is -2, this would be -2 squared. 4 times 4, 16, minus 12 is 4 plus 11. I get 15. Equals, this is -2 for x, it'd be 4 minus 2 is 2 plus 3 is 5. That's nice. Thank you, A. Oh, I forgot. We never did write the answer up here. Don't forget the answer is, see how that can reduce. So we're going to do that next. Right, plus, actually, excuse me, minus, because B is negative. minus 3 over 2 x plus 1. And let's see, where'd you go? C, 7/2. So plus 7 over 2 x plus 1 squared. And then I can make that a 4 over x. Yeah. So that's the answer. So don't forget to combine all the stuff you find here. Needs to be combined there. Now here, this one is, well, let's see. Let me ask you guys, where do you think I should go from here? All we know is A down here. So what should I do next?
I did A plus B is equal to 4 because we know that it's going to be like AX squared. and
Let's
then
catch everybody else up. So,
squared.
yeah, I got you. AX squared plus BX squared. So A plus B must be 4. So now I'm going to know what B is. I like it. So B is 1. And then one of the quickest things for C is that, see how you get 2C plus 3A? What's 2C plus 3A have to be?
11.
11. That's the only, so the terms that have no x's must equal the term that has no x's. And where was A? A is 3, so that's 2C plus 9, so 2C equals 2, so C is 1. Neato. So then the answer would be 3 over x plus 2 plus 1, 1x. X plus 1 over x squared plus x plus 3. Shlabam. Now, I really hope somebody out there is like, this is one of my favorite things from way back when, is partial fractions. I just love it. I love the idea of equating coefficients. That's such an awesomely simple but powerful idea. And it's okay if I'm the only one in the room that feels that way because I'm used to that. But this is so neat. Okay. Is that better? Do you guys feel better about that? All right.
I have a question.
Yeah.
To also find C, can't you technically do like AX plus 2BX plus CX equals 6? Since you already know A and B.
X
It would be like
plus,
the same thing, right?
yeah, totally.
Okay.
There were multiple ways, and I always just go for the way that's got the least to write, but it doesn't matter. You go for the way that you see, right? That's kind of a problem I had. I would always try to figure out the shortest way to do something, but even trying to do that, I would be wasting time trying to figure out the short. I'm like, just do the way you see, because otherwise you're wasting time. All right, so somebody asked me about, what's the next thing here? Angular linear velocity problems. So you guys remember those ideas? Let me see, I'm gonna clear all the stuff I have up here right now. You guys ready? Here it goes. So let me ask you a couple things. What is the arc length? What is this length? Does anyone remember?
Is it R over theta?
Watch how you know. I mean, what if I asked you this? What is this length? Right?
Two pi radius.
Yeah, isn't that this formula? How far did I go? How many radians? What's the angle here that I went through?
2 pi.
2 pi. So let me put a 2 pi in. So that would be 2 pi r, which is known as the circumference. So that is the same formula just for parts of the circle instead of the whole circle. Do you guys get that? Same thing. Yeah. I like how this looks like somebody's sleeping. Put an ear here. There we go. Some hair. All right. What about, so I don't know if you guys remember this, but theta is the polar. Now I can talk about this in a different way because we didn't have polar coordinates back then, but theta is the polar walking variable. Like I change theta that I walk along. And if I want to change that to a distance, like a linear distance traveled, I got to multiply by r. What was the, I don't know if you guys remember, what was the symbol for angular velocity? Like how fast I turn. What's the symbol for angular velocity? I am the alpha and the, huh? No? I am
Is
the
it like
alpha.
a curvy W?
Yes, curvy W. That's exactly, I am the alpha and the curvy W. That's right. Curvy W. Right? So that's angular velocity. So if I want to change that to a linear velocity, I actually do the exact same thing. It's really, really cool. Multiplying by r sort of converts between angular stuff and linear stuff. It happens here. It happens here. It's crazy. Let me think. I don't know. All right. I'll tell you this. How about this? I don't normally tell people too much about what I'm going to put on the final. I could have something like this, but I'm not going to talk too much about angular stuff. In fact, I'm just not going to put angular stuff on there. So feel happy about that. For number one, I'm not going to put it on number two. I told you, right? I normally don't. What could be on the final? Anything. Well, now I'm telling you this won't be on the final because we really didn't do too much with this. But I'm glad you got exposed to this idea. That's part of what we do here. And I'm glad you got exposed to the sleeping circle dude. All right, let me see. What was, all right, hold on. Let me see. Did somebody else? So after that, that was angular linear velocity sequences. Okay. How to get a formula just by looking at a sequence. Okay. So if I have a sequence like, oh shit. Where am I at? Oh, this should be interesting. Oh, what is that? I don't know. Now see, I was nice here, right? Because I could have reduced this and I could have reduced this, which makes it harder to tell, but I didn't. What sequence element is this? How do you denote this? What's the symbol for this sequence element?
A1.
A1, I like it. So A1, and that is when n is 1, is 2 over 5. N is 2, A2 is 3 over 15. So can you start to see what AN is? When n is 1, I get a 2 on top. When n is 2, I get a 3 on top. It's 3, I get a 4 on top. So when n is n, I get a huat on top.
N plus 1.
I love it. So do you see, I like your question, but I want you to see how it's not quite right. You do want to do this thought process for yourself. You do want to explicitly show yourself A1 is this, A2 is this. How are these built based on what sequence element I'm on. So what about the bottom? What the hell's going to happen with the bottom? A1 is 5, A2 is 15, A3 on the bottom is 45, right?
Is it a of n minus 1 times 5 or times 3?
Did I even know what I meant? I think I knew what I meant. I don't know what I meant. So say it again, sorry.
A to the n minus 1 times 3.
A to the n minus 1. I'm not sure. So this is 5 times 1. And we're going to see in a minute. This is 5 times 3. This is 5 times 9. And this one is 5 times 27, right? So this one really is 5 times 3 to the 0, 5 times 3 to the first, 5 times 3 to the second, 5 times 3 to the third. Do you see what the thought process I went through? I'm trying to see what is it that's changing from this to this to this? What's actually happening?
Would it be 3 to the power of n minus 1?
3 to the power of n minus 1 times
5.
5. Okay, I like it. There you go. That was really gross. I like that. But again, what's more important when we do an example is what motivated me, motivated? What got me to go the direction I went? What was I looking for? Can you look for the same thing? So with sequences, it's always first term, second term, third term. Okay, n is 1, n is 2, n is 3. Where's 1, 2, 3 showing up? Or maybe like this one, it was n minus 1, n minus 2, right? You've got to try to break things down to its parts so you can see what parts you have control over. 5 just seems to always be there. Okay, 5, be there. And then this one is changing in a very regular pattern that I can capture. Does that make sense?
Can you do
No.
another one, please?
Sure. Let's see. All right. Let me take one out of the book so I can do it. So when we both do it, we're both doing it. So, because that one I already knew the answer when I created it for the most part. Let's see. Where are you? Sha. All right, here we go. Whoa. All right, so here, which one of these looks nice to you guys? Which, ooh, I know what I would like to do. That looks funkadelic. All right, I'm gonna pick one in 5, 4, shit, 3, 2, 22. That's not the one I want. Okay, well, let's do 22. So what are you guys gonna start to look at here? I mean, it really is sort of a puzzle. You kind of rule out an easy thing. Do I keep adding or subtracting the same thing or something?
No.
Nope. So let's see now. Let's not go away from that because I'm obviously not multiplying by something, right? Do you guys see how 22 is not based on multiplication? So what do I do to -4 to get to 2? I add 6. Is that cool? What do I do to go from 2 to -10? I have to subtract
12.
12. From -10 to 14, I got to add 24. From 14 to -34, I have to subtract 48. That's kind of funky. Do you see how it's alternating, right? It's going to have like a negative 1 to the n kind of a thing like we talked about. So A1 is -4. A2 is -4 plus 6. A3 is -4 plus 6 minus 12. So it's -4 minus 6. Let me see, is there an easier way to do this? It's not a recursive formula.
Recursive is 13.4, so this isn't recursive.
Yeah. No, it's actually in here. 13.4 was series. Recursive formulas are in here, but there's like a later problem that's recursive. So let's see. What else can we do with this thing? So this one's more interesting than I thought it would be. Let's see. So A1 is -4. A2 is 2, which is -4 plus 6. Let's do this. So it's -4 plus 6. And then A3 is -4 minus 6. I don't know. You guys with me? Isn't that so? This is -4. This is 2. This is -10. A4 would be -4 plus 18. It still isn't looking too good, is it? So it can't be based on -4. A5 would be -4 minus 30. That's looking disturbing. Let me see. What else can we do with this? I mean, this one is better recursive, but that's not what they want. They don't want a recursive thing here. Let me see.
You could do -2 to n minus 1.
-2 to the n minus 1.
Maybe, and then just shift it back so that works for the first term. I don't know, I'm trying to remember what I got for that question. I think we did it in the homework.
The answer, I have it from the homework.
No.
Okay.
Well, I don't want to take forever either. I got stuck on thinking like this. But that's not the right way to look at it.
I think -2 to the n and then the whole thing minus 2 works.
Yeah.
Oh, you mean okay. So what I did wrong here was put parentheses in there. -2 to the n. So -2 to the n. No, that can't be right either.
Well, -2 would be in parentheses and then just -2 at the end. I think that works.
Oh, I see. Yeah. Okay. That works. Oh yeah, that does work. Okay. And you can see that it's based on 2 somehow, right? With that work there. Yeah, but that's a nifty one. I like that one. Which is probably why I signed it, but I hadn't done it forever. The one I was curious about was number 23. Right, why is number 23 kind of gross? What might have happened there in number 23 to make it a little harder?
They reduce the fractions.
Yeah. And you've got some clues as to how to rewrite them, right? Because there's a 3 there, there's a 5 there. So of course, how should this probably be rewritten?
Eight over 4.
8 over 4, I like it. So let's see, let's make some rooms. 4/3, 8 over 4, 16 over 5. So of course, this one can be written as
2, 2.
2 over 2. And then you've got, this one is kind of interesting. And then you can see the pattern. This one's a little more obvious where it's coming from. Right? So what would the nth one be? So here's when n is 1. So a1 is 1 over 1. A2 is 2 over 2. A3 is 4 over 3. So the bottom seems to be nice. The bottom is just going to be what?
N.
Yes, because whatever n is, that's what the bottom is. And the top, of course, looks to be based on 2, like the last one we did was, but less sneaky.
Is it 2 times a to the n minus 1? Or a n minus 1?
Yeah, it's just 2 to the n minus 1. Yeah, again, it's not recursive, so you don't want to bring a in there or something. Right? So each of these is just the power of 2. But this is 2 to the 0 power. This is 2 to the first power, 2 to the second power. So it's always 1 less than which element I'm on.
Just really quick before the class ends, the matrix problem that you had on the
Oh, yeah.
practice final.
Somebody had reminded me, I said I would do that with you. So let's do that real quick. I'm going to clear all this away. Yeah, because I left that. Let me pull that up real quick. Where are you? There you are. Yeah, so this one, there it is. Okay. Yeah, this problem I said we do together. Oh, I see. This is the eval. Oh, Jeff, I remember this. So this is my practice test from like 6 years ago. And can you see the evilness? So that's supposed to be a Z right there. So I don't know if any of you guys tried it. You're like, well, screw you, Jeff, but oh well. So let me see. Let's take it over here. Does somebody have that written down?
Have what written down again?
Just this here.
Yeah, I think I've got it.
Yeah, because I'm going to move over to some
got it.
space. Okay, so give it to me. What is that as a matrix? Let's see. Maybe I can do it. 1, -1, 2, 3.
Sorry, I forgot I was muted.
Go ahead.
2, 3. -2, 1, -3, -4. 4, -3, 1, -8.
All right, so hopefully you guys understand this kind of stuff is actually kind of nice. We just had to get used to how to manipulate the matrix, but it's just a bunch of multiplying and adding. I mean, it's kind of beautiful. And you could actually, you don't have to start on the first column. You can start any column you want to, but whoa, okay, all right, just a minute. Let me see. All right, I don't know what 22 is from, I guess from the other side. All right. Which column do you guys want to start on? Do you want to start on the first column? Okay, sure. And this feels familiar. I feel like I did this somewhere, but do you see how I could just take row 2 and double it and add it to row 3, right? So I'm going to take twice row 2 plus row 3 and put the answer in row 3. Oh, let's see. I didn't really give myself enough room for this. So this is going to be -4. Oh boy, Jeff. -4 to, this is going to suck. All right, wait a minute. All right. This is a note to yourselves. Give yourself enough room. I don't know which way you guys do this. I'm going to want to do 2 things at once, so I need some room. So this will be -4 to -6, -8. So this will be 0, -1, -5, -16. So all I'm doing is adding like these 2 things together, right? And adding those 2 rows together. And I'm done with it now. I'm done with you. Done with you. Go away. Now I can take twice row 1, add it to row 2, and put the answer in row 2, right? Because that'll kill this -2 here that I don't want. So this will be 2, -2, 4. Why are you way over there, negative? 6. So this will be 0, -1, 1, 2. Interesting. All kinds of ones in this one. This is a nice one. All right. It doesn't take much, as we have witnessed, to screw these up. All right, I don't hear anybody yell at me, so I'm going to keep going. I'm going to change the signs on row 2. Do you guys see that? I'm going to change the signs on row 2, because then I can use this one to kill the ones around it. And I'm going to write down what I'm doing. You can see it. 1, 0, 1, 1. 0, 1, -1, -2. And then I can add these 2 together. So I get 0, 0, -6, -18. And what's beautiful about the last row there? Besides 18's hairdo. I don't know what's going on with 18. Shit, I lost my 6. Whoever's still with me.
Divide by
What's nice?
6 and make it.
Yeah, divide by -6. I like it. And now I can use this to kill these 2, right? All right, so that was apparently past Jeff designed that to be really nice. So let's see, 1. Where am I at? Yeah, I can use this one. So I'm going to subtract. So I'm going to do row 1 minus row 3. Put it in row 1. You could do it, Jeff. 1 minus 0 is 1. 0 minus 0 is 0. 1 minus 1 is 0. 1 minus 3 is -2. And then I'm going to do row 2 plus row 3 and put the answer in row 2. 0, 1, 0, 1. That kicks so much ass. So it looks like the answer is -2, 1, 3. It looks like. Oh. All right. I'll tell you this, just because, especially because we don't have that much time left. I don't think I'm going to ask you to do a polar curve by hand. I am going to make you work with polar coordinates. Are you guys understanding me? And I also leave it open to the idea that I might ask you to do a parametric graph. So there's somebody was asking me about polar and parametric curves. I don't know. We've done several of these, but What would be something interesting, Jeff? I don't know. Let's do, let's see. Sure, I like it. Kind of funky. And let's say t from 0 to that's kind of gross, isn't it? Let's make this, change this. Hold up. Let's make one change. Get out of there. Let's make this pi t. I like it. Ha ha. 0 to 2. Kick ass. Oh, Jeff. Get out of there. So you got t, x, y, right? So you're using your behind the scenes dude to create your points. So there's one kind of main variable, we call it the parameter, behind the scenes creating the actual points we see, which is kind of neat. So when t is 0, you get, what do you get for x and y?
0.
Yeah, both of them are 0. I like it. Let's see, when t is, now see how there's a pi in there, which is neat. So I can do like 1/4 or something, right? Because I can do sine of pi over 4 is like 0.7, right? It's rad 2 over 2, which is rad 0.7. And when I put a 1/4 into there, I get something. Good job, Jeff. What do you get? 3/4, which is 12/16 minus 1/16 is 11/16, which is 1/16 is like 0.06. So 11/16 is going to be like 0.66. I don't know what I'm talking about. Let's see.
0.69.
69. Okay, I'm close. So we'll call it 0.7. Look at that. It's neat. Sorry. And then 1/2. I mean, it's less the specifics. It's more just the general idea. I'm going to input things that are within the given thing that make sense with the functions that I'm given, right? So 1/2 sine of pi over 2 is 1. When I put a 1/2, I get 3/2 minus 1/4, which is 6/4 minus 1/4 is 5/4, so 1.25. You guys can check me on that. I don't know how much I can trust myself. Is that all right out there? Maybe we can take a bigger step here. Let's go to 1. Let's see. Let's be crazy. Sine of pi is 0. 3 minus 1 is 2. That's huge. It's good news. So let's see what we got so far. We got 0, 0, 0.7, 0.7, 1.25, 1. Okay, this is really interesting. 2, 0. Oh, this is so cool. Yeah, I made this thing up and I have no idea what it's going to look like, everybody. Where am I? Oh, yeah. So now let's try to do 1.5 here. Sine of 3 pi over 2 is -1. And when I put a 1.5 in there, which is 3/2, I get 9/2, which is 18/4 minus 9/4 is 9/4 is 2.25. That's kind of nice. Sounds about right. I don't know how I'm doing, guys. So where am I at? 2.25, 2.25, -1. It's really funky looking. And then let's try to take a big step to 2. 2x is 2, it looks like, right? 6 minus 4, yeah. And then at 2, sine is 0 again. So I get to, well, that's kind of funky. It goes back to 2, 0. I might want, now real quick. So this is the thing about, I can't remember what video I made or something that I was trying to show you. Remember with the pi over 12 steps, and I was like, I better do some more, I need some more resolution. I don't know if you guys remember that. But see how like I'm right here now, but I'm supposed to go back to 2, 0. So in what manner do I do that? So I need some more resolution. So let me do like 1 1/4. So I'll need another little thing here. I don't know why I'm writing as 1 1/4. It should just be 5/4. So I can see where I am between these 2 points here. And then I'm going to do another one between these 2 points there. I have no idea if you see what I'm doing. I could have been more careful over here, but I thought, let me try to take big steps and see if I need little steps. I'm like, oh shit, I need little steps. Damn it. So I need 1 1/4 and I need 1 3/4. And again, I don't know why I'm writing it like that. I can write this as 5/4 and 7/4. That would be better. Right. So then when I plug a 5/4 in, why am I still doing this in my head? 15/4 minus 25/16 is 60 minus 25 is 35/16, which is 2 3/16, which is like 2.2, I guess. I don't know. Nobody's going to help me. It's all right. And then sine of 5 pi over 4 is rad 2 over 2 again is point, wait, where am I at? 5 pi over 4. Yeah, so it's going to be negative 0.7. And again, I don't hear anybody saying a damn thing, so I'm assuming everybody's with me. And I'm hoping somebody's double checking this in the calculator because I'm just being stubborn and not putting in the calculator. 7/4. Did somebody do that already? 21/4, which is 48/16 minus 49/6 is negative 1/16, negative 0.6, negative 0.06, 07. .19, okay. 2.2 then. Neato. And then 7 pi over 4 is now over there, still negative 0.7. So that's neat. So that's interesting. So that's not good enough. Damn it. So 2.2, let me see. 2.2. That is so interesting. It might do that. It might actually just go there and then come back on itself. Because both of these are, to some degree, periodic in a weird sense. All right, so that's kind of a funky one. And you can double check what you get in your calculator, but I don't know. So again, I really am not a fan of getting bogged down in the particulars of a specific problem. It is, I am not going to give you this problem, am I? No, I'm not going to give it to you. I'm going to give you another problem. So what is the main thing? So I look for, did I give you a range to work with for your t values? Then you got to figure out, well, how big of a step size should I use? So I should have used a more, how did I tell? Because I couldn't see how it was moving between some points. So I needed some more resolution. Do you guys understand that? That's because it's up to you to figure out what you're going to plug in for t. And if you don't plug enough in and your answer is beautiful, then I know you didn't do it yourself. I know you just copied it out of your calculator. You know who I'm talking to. So yeah, your work really has to inform your graph, right? So I'm cool with the fact that maybe my graph is not perfect, but it comes off of my work that I've done. Hopefully, if I've looked at this right. I don't know. I like your face. Is it not? How does it look? Let's see. You got to remember what
It's really gross.
What the domain is. Did you change your t values? Your what do you call it? The range that your t's go. Shit.
That'd be under max and min, right? T max and T min.
Yes, there you
Okay.
go. Sine pi t, and then t min is 0, t max is 2. Oh, that's kind of funky. Yeah, that's basically what I got. Let's see. Let me get a better window. No shit. Jeff, there we go. Yeah. Ooh. And it takes off from there. Oh, yeah, because I'm not even. No, what did I do? Oh, it went to 2 pi. No, I want 2, not 2 pi. Okay, I see. It actually looks really cool if I go even further than this, but it's basically what I've got. If you guys try it on your calculator. If you give yourself a bigger domain, it actually gets very interesting. Let me show you. Oh, that's so cool. All right, let me show you real quick. Hold on. How will I do it? Yeah, let's do it like this because then it's more intriguing. All right, here we go. For the 2 people that are still there with me, hold on. Let me focus. Why won't you let me focus? Oh, because I'm sharing. Hold on. Oh, focus. There we go. Now watch. All right, that's still not focused. Oh boy, this is really. All right, now let me hit graph. Where's graph? There's the part, and then it comes back and it goes. It's so awesome. And of course, and I really want you. So if you look at the parts of what we just did I just destroy what we did? I might have. I don't even know where we were doing that. Where was that? Shit. Yeah, because I was using the wrong thing. All right, well, that's too bad. But I know I'm blurry again. The y, let's see, the x piece was parabolic and the y piece was sine. So the x piece was, screw it, I can't make this point. It's too bad, Jeff. The x piece, the x values go from like negative infinity to the vertex back to negative infinity because there's a downward parabola. So that's exactly what that showed me was it went, the x went there and then it came back. And the y's would just make a sine function as the x's were doing that. And the x's would go faster. The x would move faster. That's why the sine was getting elongated as it went backwards. So parametric stuff, I mean, this is just introductory stuff we're doing here. But you can really kind of tell ahead of time what something's going to look like if you just think about what the parts are. And I think that's enough. I don't know what the 22 was I'm sorry. But I think that is it for tonight. Do you guys remember, did I do this yet? Did we talk about how tomorrow's going to work? No. So let me do this real quick. So if you look, so hopefully you guys maybe got here through this link. There's my link for tomorrow's office hours. I got more office hours tomorrow, 1:30 to 3. That's for all my students. And then of course, specifically for you guys, I have office hours 5 to 6:05. The final officially starts at 6:05. Log in before 6:05. A few minutes after 6:05, I will not let anyone else in because the final will be accessible starting at 6:05. If somebody shows up 10 minutes after that, I have no idea if you've been doing anything with that final already or not. So, but if you have technical issues, I am not going to fail you because you had technical issues. That's bullshit. Just let me know. Just the minute you can, send me an email and say, oh my God, my entire internet went down. We've been in the dark. Please don't fail me. And I'll say, too bad. No, I'll say, okay, we can work something out. You can take the final again sometime. Does that make sense, everybody? Any questions about tomorrow? Or not tomorrow, but yeah, tomorrow. You guys are tomorrow. I got 3 finals. I don't know when they all are. So our final tomorrow, 6:05 to 8:05, and I should have them graded by the next evening. And you can email me after you're done and ask me how you did, and I'll email you back when I'm done. It's crazy. All right. And I normally bring cookies for the final, but you'll have to BYOC. Bring your own cookies. I'll bring my own cookies. All right, guys.
Thank you.
You're welcome. That is plenty. If anyone else is still out there, have a good night.
Professor,
Yes.
I was looking at my grades and I realized that you never graded my quiz 7.
Interesting. All right, let me look you up here.
I sent it to you through